Problem number 3. Okay, it says radial density. So that means the number of people per square kilometer is going to change as you move further from the center. Radial means from the center moving out. So if the town center was here at a certain distance out on that ring, there'd be so many people as a function of r. So it'll depend on how far out you are, how many people per square kilometer are there. Okay, so we need to count all the people on all the rings from the center to 5 kilometers out. So we're going to count all the people add up all the people on all the rings from 0 to 5, and a ring has an area of 2 pi r, the distance around, times dr. The thickness is a small change in the radius, at a radius at r, 2 pi all the way around times dr. That's the area of the ring, times the people per square kilometer. That would be the number of people per area. That would be 9,000 times 1 plus 0.1 r squared to the minus 2. So, constants that we can pull out. This cannot be taken inside because there's a power on this. We can take it out, take the 2 pi out. We can have 9,000 times 2, 18,000 pi integral from 0 to 5 of r times 1 plus 0.1 r squared to the minus 2 dr. The minus 2 cannot be distributed because this is addition. It could be brought in if it was all just multiplication, but it can't. So let's do a U-substitution for the stuff inside, because the derivative of this is going to have an r in it that'll probably cancel that r. So we're going to let u equal 1 plus 0.1 r squared. du would equal, derivative of 1 is 0. Derivative of this part would be 2 times that, r to the 1 dr. Solving for dr so that we can substitute it, we'll be dividing by that. So du over 0.2 r equals dr. All right. So this becomes 18,000 pi integral, changing this. So 5 squared is 25 times 0.1 is 2.5 plus 1 is 3.5. Putting in 0, that becomes just 1. We have an r that we're hoping disappears. We have u to the minus 2 and du over 0.2 r. The r's cancel. 0.2 is less than 1 when we pull it out and divide it in. Some people got a smaller number. It should get bigger because that's less than 1, so it's going to go in more times. So 18,000 divided by 0.2 is 90,000. So we have 90,000 pi integral of 1 to 3.5 of u to the minus 2 du. Now it's a minus power, which means it's 1 over u squared. That is not ln. ln is only 1 over u. Simple. No others. So this, we use the power rule. It's not minus 1. If it's minus 1, it's ln. Otherwise, it's not. So this is going to be, add 1 to minus 2 is minus 1. and divide by the minus 1. That's the power rule. Evaluated from 1 to 3.5 of 90,000 pi times this. This is 1 over u, so this is minus 1 over u, evaluated from 1 to 3.5. So we get 90,000 pi times minus 1 over 3.5 plus 1 over 1, which comes out to be, oh, what was it? Let's just do it. Minus 1 divided by 3.5 plus 1. 2. What did I do wrong here? Oh, didn't get rid of that. Minus 1 divided by 3. Yeah, there we go. 201,960 people. Derive the formula. Whenever you're deriving the formula for a pointy one, it tends to be advantageous to put the coordinate system at the point. Because when it's a straight line like this, you've got similar triangles. Okay? So, we need to label things. The large radius is capital R. The height is capital H. We're going to call this something. How about X? And this is Y. And the slice that we're going to take, and we're going to add up the volume of all the slices, but this particular slice is pi x squared times the thickness, which is dy, integrated from, and y is going to go from 0 to h. So this becomes integral from 0 to h. We got a problem here, so we got to solve this. And x, we're trying to replace the x, so I'm starting with x. X is to y as r is to h. Multiply by y. And so I'm going to have a pi that's a constant, comes out. And I've got this for x that I got to square, so it's going to be r squared y squared over h squared dy. The capital R squared and capital H squared are constants. They come out, so we get pi times r squared over h squared times, we have a y squared integrated, it's y to the third over 3, evaluated from 0 to h. You put in an h, put in 0, you get nothing, so you're going to get, that's an h, pi r squared over h squared times h to the third over 3. 2 of these will cancel 2 of those and leave 1 h and a third. So we get 1/3 and a pi and an r squared and an h. 5. If I'm going to reflect it over x equal minus 1, it's going to go this way. So I'm going to move my axis over so I got room for it. I'll put it here. Hopefully that's far enough over. And I'm in the first quadrant, so I'm going to put the x-axis here and the y-axis here. And 9 minus x squared, that's an upside down parabola. Move up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. If I move over 1, it's down 1. If I move over 2, it's down 4. If I move over 3, it's down 9. There is the graph where this is 3. X equal minus 1. It's mirror image. This would go to here. This would go to there. This would go to there. And this would go to 1, 2, 3, 4 from the axis. 1, 2, 3, 4. There's the image. Disk method. Slice perpendicular to the axis. The axis is this direction. Perpendicular to it is that direction. So I'm perpendicular but in the area, so I'll just pick there. Its image is over here. It's going to go from here around to there and around here, around that center. So it's going to be something like that and something like that. And it should look like a washer. A large circle minus the inside circle. The thickness of this slice is up and down, so it's a dy. So our integral should be, for the y is going to go from 0 to 9. And when we got a circle minus the circle, we're going to do subtraction. Pi r squared minus pi r squared. Pi large radius, that's all the way over. Well, if this is a point on the circle, x, or on the curve, x, y, x is this direction, y would be this direction. X is in the direction of the radius, but the x is not the total radius because it doesn't reach to the axis of rotation. It's one more. So the pi r squared is x plus 1 squared minus pi, the small radius. Well, the small radius all the way up and down is 1, so that's 1 squared. Pi r squared dy. This is the only problem. We need to replace the x. X is equal to, if we solve for this, y equals 9 minus x squared. So we add x squared, subtract y, we get x squared equals 9 minus y. Take the square root, and we get pi, integral from 0 to 9 of x, which is square root of 9 minus y, plus 1, quantity squared, minus 1 squared, which is 1, dy. Now, I'm going to work this one out for you so you can see how this one, if you chose this one, what you would have to do. So we'd have pi, and we'd have an integral from 0 to 9. This squared is going to be square root of 9 minus y plus 1 times that again. So I'm going to get the square root times the square root, which should get rid of the square root. Then I'm going to have plus 1, this times 1, that's plus 1 square root, plus another square root, so plus 2 square root of 9 minus y, plus 1 squared minus 1. So those cancel, the plus 1 and minus 1. And so I have this to integrate, which should be pi. 9 to integrate is 9x, or y. Y integrated be minus y squared over 2. And then this integrated, this is like this to the 1/2. So we add it, so that'd be 3/2. So we'd have plus 2 times 9 minus y to the 3/2 divided by 3/2. But then there's inside has got a minus 1. So this is going to change this to a minus quantity using the chain rule. evaluated from 0 to 9. So it'll be pi, 9 times 9 is 81, minus 81 over 2, minus 4 times 9. 9 minus 9 is 0, so all of this would be 4 times 0, so that's nothing. That's with the 9 in, minus, and if I put 0 in there, that's 0, that's 0. But if I put 0 in here, I get 9 minus 0, which is 9. Square root of 9 is 3. Cubed is 27. Divided by 3 is 9. Times 4 is 36 negative because of the negative. And if you take your time working that out, you'll get the correct answer. Okay, now let's do it the shell method. So shell, we slice parallel to the axis, so I'll just do it out here, which would end up over here. And it's going to come around the axis, so like that and like that. That's a shell. That's a thin shell. The thickness of the shell is this way. The wall is dx thick. And shells are the distance around, which is 2 pi r, and r is this direction from the axis over, so this much is again x plus 1. So there's 2 pi r times the height, which is y, but y is 9 minus x squared. And x is going to go from 1 to 3. We don't do from minus 1 to 3 because we don't want the inside. From 0 to 3, excuse me, 0 to 3. So we'll multiply this together. We have 2 pi integral from 0 to 3, x times 9, x times minus x squared, 1 times 9, 1 times minus x squared. The integral of this, 2 pi, 9x squared over 2 minus x to the 4th over 4 plus 9x minus x to the 3rd over 3. Evaluate from 0 to 3. X in each one of these, so when I put in 0, we're going to get nothing this time. Not up here. This time we will. But we got to put 3 in there, so we're going to have 2 pi. 3 squared is 9 times 9 is 81 halves. 3 to the 4th is 81 divided by 4. Plus 9 times 3. 3 to the 3rd is 27 divided by 3 is 9. Figure out that fraction. Oop. Oh man, I did all that where you couldn't see it. All right, let's say it again. I forgot. The picture's up here and this is down here. I'm so sorry. All right, do this again. We have the integral 2 pi r, 2 pi r, so 2 pi, the r is x plus 1, and then this direction is y, which is 9 minus x squared. For a shell, it's the distance around, 2 pi r times the height times the thickness, which is dx, from 0 to 3. Then if you FOIL this out, you should get this. x times 9, x times x squared, minus x squared, 1 times 9, 1 times minus x squared. Then you integrate it, put in the 3, and you should get that, which will give you hopefully the same answer as you got up here. Okay, and the final problem. I'll try to keep it on the screen. All right. Y equals x squared goes from 0, goes to 1, 1, 2, 4, and 3, 5, 6, 7, 8, 9 up here somewhere. If this is spun about the y-axis, it will make a nice parabolic tank. It's a circular paraboloid called, but we'll go with this. 3, 9. Now we're going to lift water out of this. So the water, we want to slice it this way so that we're lifting all the water of the slice to the same height. So if I slice it this way, making a disc, it's going to be up and down dy thick. So we got mad, and the mass is, in this case, it's water. So the density is 1,000 kilograms per meter cubed. So we have to take it times the volume. So we need the volume of that disc. Well, it's going to be pi r squared. That's the area times the thickness. Volume, density, times a, the acceleration due to gravity, times the distance we're lifting the water. Well, we're lifting it to the top. And since we have the coordinate system here dictated by the equation y equals x squared, then the top is at 9, and we're lifting it, not y, which would be from the origin to the thing. It would be this distance, which is 9 minus y. That would be the work to lift that one slice. And then we have to add up all the slices from, this is dy, so from 0 to 9. Pulling out any constants, pi, the 1,000, the 9.8, we get 9800 pi. Integral from 0 to 9 of r. R is the radius of this, which is also equal to x. We need r squared. Well, r squared would be x squared. Well, x squared is y, and we want it in terms of y, so r squared is just y. Times the 1,000 we got out, the 9.8, the pi, that's out, that's out, that's out, that's there. And then we have a 9 minus y dy. The dy, the 9 minus y, and r squared is a y in this case. So this is which is going to integrate to and when you put the 9s in, so 9 squared times another 9 which should be 9 to the third, or 729, I believe, over 2, minus, this would be 729 over 3. A half of it minus a third of it is a sixth of it. So it's 9800 pi times 729 over 6. And not multiplying those. I'm getting common denominator, multiplying by 3 and multiplying by 2. And that makes the denominator 6. And I got 3 of these minus 2 of those, which is 1 of those. And that equals the answer if you figure that out. Okay.